So welcome to another video for Advanced Higher Chemistry. This is still on inorganic chemistry, and this should be our final video on the topic of orbitals and electron configuration. And this is quite a small area, but it's one that's quite important, and it's going to be relating our new understanding of how the orbitals are filled and electron configuration to trends in ionization energy. So ionization energy at higher, you were taught that there were two trends when it comes to first ionization energy. Firstly, that it increases across the period due to increased nuclear charge. And secondly, that it decreases down a group due to increased number of filled electron shells and an increased screening effect. Now, the trend of it decreasing down a group is completely true. However, there is a slight variation in the definite trend that first ionization energy always increases across the period. It does not always increase, but it definitely increases in general. The reason for slight variations are due to the fact that we have these subshells, and depending on whether these are filled or halfly filled, we are going to get slight variations. And we're going to see when we look at a graph of first ionization energy that there are some anomalies in the trend of always increasing that you might have seen last year if you looked in detail. So we're going to be focusing on the graph at the bottom for first ionization energy. I've done the first period, the elements are written in blue, the second period they're written in green, and the third period they're written in purple. You can see that as you go across each period, there is a definite increase, a general increase in ionization energy as you go across the period. Helium is higher than hydrogen, neon higher than lithium, and argon higher than sodium. However, if you look at the actual pattern within the line, it is not always increasing. There are two areas where we're seeing a decrease for each period. So the first area where we see an issue is between beryllium and boron for the second period and magnesium and aluminium for the third period. This is between elements in group 2 and elements in group 3 of the periodic table. So we see a drop in ionization energy between group 2 and group 3. This is because group 2 elements have a completely filled S shell, and filled orbitals are stable. Group 3, that is when the first electron gets put into a p orbital. So we've got 6 possible locations for electrons, and we've put 1 electron into the p orbitals. That is slightly less stable than just having a completed s orbital, and stability is related to energy. So if it's less stable, you're going to need less energy to remove the electron, so you get a slight decrease. So all you would need to say, why is there a drop in ionization energy from group 2 to group 3? That is because a filled s orbital is more stable than having a single electron in a p orbital. The second area in which we see a slight break from the trend in increasing first ionization energy is between nitrogen and oxygen in period 2 and phosphorus and sulfur in period 3. That is the difference between group 5 and group 6, or group 15, group 16, depending on which way you want to count the groups. And these come at the halfway point of the p block. So because we're getting a decrease in energy, that means there is a decrease in the stability of group 6 compared to group 5. Group 5 elements have 3 electrons in the p orbitals. Because of Hund's rule, that is 1 electron in each of the p orbitals. When we go to group 6, we are adding in 1 additional electron. That electron must pair up with one of the electrons that is there. Electrons repel one another. They don't really want to be paired up. So the fact that you're having to introduce this paired electron makes it slightly less stable, the electron arrangement, and because it's less stable, it's going to be easier to remove an electron. Now, you don't need to remember where these changes occur, the exact elements. You have access to the first ionization energies in your data booklet. I always forget what page it's on. First ionization energies are on page 12, and that gives you more ionization energies than you need to know, but you'll be able to identify where it's slightly dropping, and you just need to be able to explain why. But it's always between the filled s orbital and having one electron in the p orbital decreases in stability, and then having 3 electrons in the p orbital is more stable than having to pair up a 4th electron. So your explanation, why do we get these slight variations in the trend of first ionization energy? Well, filled subshells are more stable than partially filled subshells. It takes more energy to break an electron out of a filled s orbital than to remove an electron from a p orbital, well, a set of p orbitals where there's only one electron. So ionization energy always decreases between group 2 and group 3. Electrons also prefer not to be paired in degenerate orbitals. So when you're removing the first paired electron within a set of p orbitals, and this also happens for d orbitals, you increase the instability by having that pairing. Therefore, you're going to need less energy to remove that 4th electron from the p orbital than the 3rd electron from the p orbital, which means that you have a decrease in first ionization energy between group 5 and group 6. So this topic is something that if you were asked anything about trends in the periodic table, you would be expected to remember that it is not a perfect increase, and that the orbital theory and how the orbitals fill and how stable the orbitals does play a role which affects this trend. Remember, as I've said, your data booklet on page 12 has all the first ionization energies, so you can see where you're getting this decrease in ionization energy for each period, and then hopefully apply some of the logic of what you know to that situation. Or if you can remember all of this directly from the video, all the better. But you can use the periodic table and your knowledge of orbitals to sort of piece together this answer.